Hi, I'm Nephi. Today I will introduce a new project. In this project, we add a new USB 3 module into an existing eMMC programming system. This is our existing eMMC programming system. There is the master socket and 8 slave sockets in this system. User can duplicate at most 8 eMMC at the same time. This is an overview of the programming system. The components include FPGA and a CPLD. FPGA reads the data from the eMMC master chip and transfer all of this data into the other eMMC slave chips. CPLD controls all the peripherals of the programming systems. All of the flow sequences are controlled by the DSP, which is installed in the programmer. A previous way to create the master chip is by using a card reader. User can save his data in the computer, then download the data into the blank chip through the card reader. But it's inconvenient to the user if they want to create multiple master chips at the same time. So we consider adding a USB 3 functions in the current programming system. This is the top view of the eMMC programming system with the USB 3 module. This is the overview of the USB 3 module. There are 3 components on it: a USB 3 peripheral chip, an FPGA, and an eMMC. Through a USB hub, multiple eMMC programming systems can be connected to the computer, and the computer can download the data to all of the programming systems at the same time. There are several buffers in the USB 3 chip, which is used to control the flow of the data, and we call the FPGA a bridge. It means that the FPGA is the bridge between the eMMC and the USB chip. FPGA moves data from the buffer of the USB chip to the eMMC. The eMMC is the master chip which is used to store the user data. There is the thread X RTOS in the USB 3 chip, so we designed the firmware based on the RTOS. We created 4 threads inside the firmware. We call them thread 1, 2, 3, and 4. Thread 1 receives the commands from the GUI and resend it to the FPGA through the I2C interface. Thread 2 receives the status report from the FPGA and transfer it into the internal buffer of the USB chip. Thread 3 moves the status report from the internal buffer and transfer it into the GUI. The final thread is in charge of the updating of the firmware. This is the basic concept behind our USB 3 module. Thanks for your watching. See you next time.